162, find peak element from LeetCode. Let's jump to the question. A peak element is an element that is strictly greater than its neighbors. Given an integer array nums, find a peak element and return its index. If the array contains multiple peaks, return the index to any of the peaks. So the question is saying an array of numbers are given and a peak element should be returned and the index should be returned. And if there are a couple of peaks, we are going to just return one, and that would be the answer. And we should do it in logarithmic time complexity. As you see in this example, like the peak element for this example is going to be 3. The reason is like this is bigger than the left index and this is bigger than the right index, and we are going to return the index, which is 2 here. We are going to return 2. In the other example, as you see, the peak element is this one because it's bigger than 5 and it's bigger than 4, and another peak element exists here, which is 2 is bigger than 1 and is bigger than 1. So we can either return 1 or either return 5 as an index of this example. Let's jump to the solution and see how we can solve this problem. When we talk about logarithmic time complexity, binary search comes to my mind. So for this question, we are going to solve this question using binary search tree. The way we do it is we are going to use 3 pointers. One pointer is the left pointer, which is pointing at the at first is going to point at the beginning of the array, and we have a right pointer which at the beginning is going to point at the end of the array, and we have a middle index which is the middle index of these two. For this case, because 6 plus 0 divided by 2 is going to be true, this is going to be the middle index. And what we are going to do, we are going to compare the middle index and the index beside it, the one beside it at the right side, and if it is bigger, we are going to update the right pointer, and if it is smaller, we are going to update the left pointer. And we try to close the smaller the gap between the left pointer and our right pointer until we find the peak element and left pointer is not smaller than the right pointer. So until that point, we're gonna keep iterating. So for this case, we start like this and we check if the m, which is like 3 now, is smaller than 5 or it's bigger than 5. So 3 is smaller than 5. What we are going to do, we are going to update the left pointer. We are going to update the left pointer to here. So this is going to be the left pointer, right? It's going to be updated to the one beside middle. So and then we are going to find the middle again, and this is going to be the middle, and we check the middle and middle plus 1, which is this is going to be 5 and this is 4, and 5 is bigger than 4, and 6 is bigger than 4, and because it's bigger, we are going to update the right pointer. So the right pointer is going to be updated to the middle. So the right pointer is going to be updated. What we are going to do, we are going to calculate the middle index for these two, which is going to be 5 plus 4 is going to be 9. 9 divided by 2, and we are going to get an integer number. It's going to be 4, so this is going to be the middle pointer, right? And we are going to check if this middle pointer is bigger than the middle pointer plus 1, and 5 is smaller than 6, so we are going to update the left pointer, which is going to be here. So the left pointer is going to be updated to mid plus 1, and now the left pointer is not smaller than the right pointer anymore, so we don't iterate anymore. So we are going to return the left pointer, which is going to be index 5, and that's the answer. That's the peak that you see. So let's solve another example. So as I said, we are going to start from 0 index for the left pointer and the end index for the right pointer. What we are going to do, we are going to find the middle index. So this is 6 plus 0 divided by 2 is going to be 3, so this is going to be the middle pointer. So we are going to check the middle pointer and the mid plus 1. So if it is smaller, we are going to update the left pointer. The left pointer is going to be updated and it's going to be here, and then we are going to find the middle pointer pointer again, and the middle pointer is going to be index 5, so this is going to be the middle pointer, and we are going to check if this is bigger than this, which is not, so we are going to update the left pointer again. So this is going to be the left pointer, and now left pointer is not smaller than the left index is not smaller than right index, so we are going to return that as a result. So this is going to be answer. So what if we have a sorted array? So it's ascending, or it's a sorted array but it's descending. So how do we deal with that? So the same thing. So this is going to be the left pointer, this is going to be the right pointer. We are going to find the middle. It's going to be 2, it's going to be here, right? So if this in this value at the middle index is bigger than the middle index plus 1, which is 5 is smaller than 6, so we are going to update the left pointer to here. So the left pointer is going to be updated to here. And now we are going to check, find the middle pointer for that. So 4 plus 3 is going to be 7, divided by 2 is going to be 3. So this is going to be the middle pointer. So if the middle pointer is bigger than the middle plus 1, which is not, we are going to update the left pointer again, which is going to be here, right? So, and that's the answer that we are going to return. So that's the peak that we have at index 4. How about the descending one? So it's going to start from here. This is going to be the left pointer, this is going to be the right pointer. So we are going to find the middle, which is going to be here. So this is the middle that we have, and then we check the middle and middle plus 1. So this number is not big, it's not, it is bigger than the mid plus 1. So what we are going to do, we are going to update the right pointer, which is going to be here. So the right pointer is going to be updated to index 2, and now we are going to find the middle index, which is going 2 plus 0 divided by 2 is gonna be 1. So middle is here, so middle is still bigger than the middle plus 1, so we are going to update the right pointer again to middle. So the right pointer is updated to here, and now we find the middle pointer again. So 1 plus 0 divided by 2 is going to be 0. This is the middle pointer that we have, and what we're going to do, we are going to see if the middle pointer is bigger than the middle plus 1. It is, and we are going to update the right pointer, and the right pointer is here. Now the left pointer is not smaller than the right pointer, and this is the answer that we are going to return. And the time complexity for this solution is going to be logarithmic, and the space complexity is logarithmic as well. Thank you.